Hello there. Today we're going to talk about one of the most foremost topics that we will discuss throughout this whole grade pretty much, which is relocation with addition and subtraction. And actually this title is a little wrong because we do also go into multiplication and division as well. So with all operations, let's just say that. Okay? So all of the big four operations, we will actually talk about them all in this subsequent video, and that's why this video is so important. We're really going to go over this in detail, and honestly the techniques we discussed today will help you solve somewhere between 90 and 95% of all problems, and then the subsequent videos will take you through some of the case studies, some weird things we see, and so on and so forth. First of all, what is relocation? And if you already know what relocation is, I actually welcome you to try this example here on the right-hand side. Maybe while I'm saying this, we'll go through it anyway, but just as like a practice kind of a thing. The objective of relocation is really to rearrange numbers in such a way where the final calculation is a lot easier. And by a lot easier, what I mean is you can do it mentally. That's all I mean. So we will work through, first of all, addition and subtraction questions that at first may not look that solvable. So you look at this monstrosity. We have 25 plus 56 minus 23 minus 5 plus 14 plus 13. And it definitely seems like, hey, this is not really something we can do. It looks difficult. It looks very nuanced. And you just don't think you can solve it that easily. But I'm going to show you a way where we can actually make this a lot easier in terms of just putting numbers together, right? So that's what the sad face represents. So the sad face sort of represents the fact that, this is basically a difficult question if we don't use relocation. But we can make this a lot easier. So if you look at, first of all, the fact that 25 minus 5 gives us an easy number to work with, right? The same thing with 56 plus 14. We see that the plus 6 and the plus 4 will give us a group of 10. And if we go back to 25 minus 5, 25 minus 5 also gives us a group of 10. And then also, minus 23 plus 13 also gives us a group of 10. So look at this. 25 minus 5, which is this first red bracket that we see here, is equal to 20, right? And so that's nice and easy to calculate. 56 plus 14 gives us 70, and negative 23 plus 13 is negative 10. And you can see those three numbers right here, 20 plus 70 minus 10. It's just a good idea to keep all your negatives in mind here. So negative 23 plus 13, we actually end up with more negatives and less positives. So that's why we have negative 10 and not positive 10. So just keep that in mind. And this gives us a final answer of 80. Which now has a happy face because now we actually see that solving this question was not so bad. At no point did I have to take out a calculator. I just paired the right numbers with the right other numbers and got to my answer. But obviously, once you get your answer, I do want you to actually use a calculator here. So I've got a calculating device right here. And I'd like to actually check our answer. So if you go ahead and just pump the original question into your calculator, 25 plus 56 minus 23 minus 5 plus 14 and plus 13, you can see my answer here gives us an answer of 80, which is precisely the same answer we get using this property, which is called the relocation property. So let's explore this in a bit more detail, right? First of all, let's only cover addition. So by addition, I mean this here. So 56 and 14, and that's the only addition one we did. So the key to addition is to always find a series of friendly pairs which assist us in making groups of 10. So what do I mean by this? There's actually 5 distinct pairs that do this. 1 plus 9, 2 plus 8, 3 plus 7, 4 plus 6, and 5 plus 5. You can see we used 4 plus 6 in the previous example where we had a 6 and a 4, which of course 6 plus 4 is equal to 10. Now why do we do this, right? What's so special about making groups of 10? Well, the main reason is just it's intuitive, right? When someone asks you what is 10 plus 10, you don't have to think about it. 10 plus 10 is 20. You just come up with that conclusion basically right away. Again, I have 2 examples here. So 20 plus 20 is equal to 40. You don't have to think it's just a bam, bam, bam type of thing. 140 minus 130 is equal to 10. Again, you don't really have to think about these. So when you look at a question like 20 plus 20, that's a lot easier than this monster question that we had here where I had to put a bit of a sad face to just recognize that it was a bit of a tough question. right? Another thing you can do is if there's already a tens digit, don't worry about it. You can just factor that in. So here we have 12 plus 18. I know that 2 plus 8 is equal to 10, so that's my first group of 10. And then I have another 10 from the tens digit over here of the 12, another 10 from the tens digit of the 18, which is another 10. So you have 2 plus 8, which is already 10. You have this 10 from 12. You have this 10 from 18. You put 10 plus 10 plus 10 together, you get your 30. You can also break it up differently. Some people know that 12 plus 8 is equal to 20. So if you just add 10 from the 18 onto that, you can also get your 30. Likewise, 18 plus 2, very intuitive. 18 plus 2 is equal to 20. The additional 10 from the 12 gives you your 30. So again, groups of 10 are super intuitive, super easy to work with, and that's why we always encourage you, when you can make groups of 10, you should make groups of 10. Okay, subtraction is a little bit different. So with subtraction, first things first, I very highly encourage, if you do see any subtraction, we'll do this with division 2 later on, just circle it. So over here I have negative 13. Just circle it. That way it'll stand out to you that I have to subtract and not add. You will see fewer subtraction signs, so that's always a good indication of what to do. Then 23 plus 86 minus 13 plus 4. This is my example in this case. When you're subtracting, again, you want to have the same. So basically, you have to find a corresponding addition with the same ones digit. So here we have 23, which has a 3 in the ones digit, and we have a negative 13, which another 3 in the ones digit. So 23 minus 13 gives us a value of 10. Nice and easy, right? And again, 86 plus 4 uses the old thing we talked about, which is a 6 plus 4 equals to 10. So we get 10. Again, 23 minus 13 actually gives us 10. So that's perfect. The easy way to think of this is just do 3 minus 3 first. So 3 minus 3 is equal to, of course, 0. And then that makes it 20 minus 10, which gives us just the regular 10, right? And then you have a plus 90. Of course, 86 plus 4 is 90. You add this up and you get 100. Now, of course, once you're done this, you can check using your calculator. 23 plus 86 minus 13 plus 4, which does in fact give us 100, as you can see in my calculator right there, right? So that's how you can use this to really develop your skills in terms of how to regroup, and not only how to regroup, but how to regroup properly and using the right convention every single time. Okay? All right, I know that was enough of me talking. I know you want to try questions and have me take them up like we always do, and here is the big chance. So I've got two questions here on the slides, and I'm gonna give you 5 minutes to go ahead and try these questions out, and afterwards we will take them up, and hopefully you'll be able to see a lot of what we talked about in action. All right. And before I leave you, I will give you a hint. There are some subtraction signs in both of these questions. So based on our previous discussion, it should be a little intuitive as to what to do first. All right? That is my parting wish to you guys, and I will see you after 5 minutes. Good luck. All right, so that is time. Hopefully you had a chance to go over these questions in person. So first of all, let's use my hint from the previous section, which is that the first thing we have to do is, of course, circle, right? We have to circle all of our subtraction signs. So let's go ahead and do that. I've got my red ink here. So I've circled minus 12 and minus 4 as our two negatives, because remember, our procedure for negatives is different than our procedure for positives, right? And so immediately we start trying to find these pairs. And it just depends on what your eye sees first. The first thing I see is 23. So 23 clearly pairs with the 7 there, the positive 7. So I'm going to put equals to 23 plus 7, right? And now I'm going to erase this, but I will keep a little baby check mark on both. So we remember we've already used that, right? The next thing I see, oh, there is one negative I forgot about, which is the negative 8. Let's go ahead and circle that. So the next thing I see is that negative 8 and 48. So I'm going to pair those now with plus 48 minus 8, right? Again, this subtends a group of 10. 48 minus 8 is, of course, 40, so that's a good choice for us to use next. And then, again, I will get rid of this, and I will put two little baby check marks. The next thing I see is all the way on the right-hand side, we do have a plus 34 minus 4. Very easy choice. This just gives us an answer of 30, so again, I will put plus 34 minus 4, right? Again, get rid of this, and two little baby check marks. And then the only thing left over is right here, which is minus 12 and plus 2. So we're going to add that, minus 12 plus 2, and that is good to go. Right? Now, at this point, we have our individual pairs that give us 10. So let's go ahead and calculate them. Now, 23 plus 7 is, of course, 30. 48 minus 8 is equal to 40. We have more positives than negatives, so our sign is going to be positive. 34 minus 4 is positive 30. Again, we have more positives than negatives, so that is that. And then negative 12 plus 2, that's an exception because we have more negatives than positives. We have negative 12 and then just positive 2, right? So it's going to give us an answer of negative 10, right? We know 12 minus 2 is 10, but the answer is negative because we have much more negative numbers than we have positive numbers in this case. And then you just go ahead and add this up. 30 plus 40 plus 30 is very common. It's just 100. Again, you can do 30 plus 30, which is 60, and then you add in the 40 later. It's just a good thing to keep in mind. And then 100 minus 10 is equal to 90, which is going to be our final answer in this case. Okay? So again, you can compare this original calculation, which we can give the sad face, and then this revised calculation, which we can give the happy face, right? It's so much faster. It's so much easier. It's so much more intuitive. So that's why we always recommend the strategy to you guys. Right here on the right-hand side, let's switch colors. Maybe we'll use green. We'll use some Christmas colors to go ahead and do that. So we have, just again, finding those negatives, right? And then the first thing we do is, again, the circling. Let's circle negative 30, negative 51. Those are the only two we really have right now. So let's go ahead and start pairing. The first thing I see is 26 and 14. So we have 26 plus 14. That can be our first pair. Erase. Check. 73 pairs with 27. Right there. No negatives to worry about, so just a nice and easy check. Now we have negative 51, which pairs with positive 151. So plus 151 minus 51. We do have more positives, so that's good to go. Finally, we have this minus 30 left over, which doesn't really have a pair, but it's not a problem. if you had a keen eye, you would notice that negative 30 already actually ends in a 0. Wonderful. Easy peasy, right? Just chuck it on there, minus 30. And watch what happens now. Well, now we make our pairs. 26 plus 14 gives us 40, right? 73 plus 27, again, a nice easy pair to remember. That's equal to 100. 151 minus 51 gives us another 100 right here, right? Very easy to, again, just intuitively keep that in your mind. And then we have right here minus 30. Now, minus 30 doesn't have a pair, but it doesn't need one. It's already part of our nice, easy, intuitive calculation because it already ends in a 0. We don't need to change that up. There's no need to fix what's not broken, right? And then you just go ahead and chuck all this together. 100 plus 100 is 200. 200 plus 40 is 240. 240 minus 30 is equal to 210. And that is our correct final answer for that situation. Okay? These are really easy questions, and honestly, 90 to 95% of what you get with respect to addition and subtraction, they look like this, and they're really easy to solve if you remember the fundamentals from the previous slide that we talked about. Okay, let's just flip this guy over, and let us continue on with the slideshow. So, relocation with multiplying and dividing is a little bit different. Basically, there's another procedure, but it's kind of the same, but not really. We start this time by, again, circling, but this time we're going to circle the divisions, right? So that's step number 1. The reason why we do this is because these numbers are what we're going to use to make things smaller, and so it's good to have them on hand whenever we need them, right? Now, the next thing I want you guys to look at is this green section here, which is 12 divided by 4 divided by 3. Now, that might not seem like much, but the reality is that that ensures that we have what is called a lowest running total. Ensure that you have a lowest running total, which means the total after you do a group or a segment should be the lowest number you can possibly find. Now, there's multiple ways to do this, and you might not always get the absolute lowest running total all the time, but it's a good thing to look out for. In this case, 12 divided by 4 is 3. 3 divided by 3 is equal to 1. And 1 is the smallest number we can have when we multiply or divide things by each other, right? Because 12 divided by 12 is equal to 1. If we remove fractions, of course. So that's what we're going to put first. Again, in the green, we have the lowest running total is equal to 1. That is fantastic because you get it equal to 12 divided by 4 divided by 3. And we put a little lowest running total thing in a circle. Now, don't do this when you actually show your work. I'm doing this to show you why we use this lowest running total concept. Then you can add on whatever's left over, in this case times 8 divided by 2. We all know 8 divided by 2 is equal to 4, and 1 times that does not change anything, so our final answer, as it says there, is equal to 4. So you keep track of the lowest running total, and I would do this mentally. I've done it here just to show you, but you want to do this mentally until you get a nice, convenient final answer. And so we've done the example while going through the instructions. 8 times 12 divided by 4 divided by 3 divided by 2 is equal to 4. Now, I want to emphasize something here. Do not just actually do the question from left to right. So if you do 8 times 12, I can do that mentally. But again, that mental calculation is 8 times 12 in actuality is equal to 96. That number is not convenient. 96 divided by 4, at that point, I would need to use a calculator, right? I'm not super whiz to be able to do that mentally. Maybe you are, and that's great. But you need to always go through the steps that I've talked about, right? The lowest running total should be your objective, because remember, you want to do all these questions mentally. You don't want to have roadblocks in between, right? Okay. We're here now. So now we're at another point where I will leave you for 5 minutes to go ahead and practice. These questions all use the principles we've already talked about, and at the end of this practice segment, I will take up each and every single one of these questions, okay? So go ahead, try this out, and I will see you in another 5 minutes. Good luck. Okay, so that is time. I know it briefly skipped over to 4:06 there, but I hope you had the 5 minutes to sort of do these questions yourself. Let's go ahead and now take a look at them one by one. So first of all, question one. Right? Really, there's no right way to do this. You just really want to make sure that your numbers have a lowest running total. Of course, we do want to circle. So let's go ahead and circle all these beautiful divisions. Right? And now we try and find things that subtend to us a lowest running total. Now, everybody's brain works differently, but for me, the first pair of numbers I identified that does this, I'm going to use the highlighter to try and point this out here, is really the 21, and then the divide by 7 here, and the divide by 3 here. Again, because your lowest running total is equal to 1. Always look out for that. So always look out for, I'm going to put this in purple at the top here. That is the highlighter. Let's use the pen. Oops. That's also not purple. Look out for lowest running total equals to 1, right? So if you keep that in mind, that's your objective, basically to find all these different lowest running totals that equal to 1, it's going to be much easier for you down the road, right? So I've already found that, so let's go ahead and apply that. So we have 21 divide by 7 divide by 3, right? So again, that chops off basically 3 from our list here. We don't need 21 or 7 or 3 anymore. Looking at the other numbers, there's really nothing that convenient that I say like, oh, that's immediately divisible by that, right? But in this case, we can make some concessions here and try and basically divide as much as we can, right? If you look at the divisions left, we have a divide by 9 and a divide by 4. Neither one of these works really well because divide by 4, 18, 6, and 2, neither of those are divisible by 4. So let's try dividing by 9. In other words, let's now go for 18 divided by 9. Let's just see how that works out. So we have times 18 divide by 9. That gives us a lowest running total of 2. 1 times 2 is 2, of course, so that's still a pretty low lowest running total. We can check those off. And now we have times 6 times 2. Honestly, there's no good way to do that. They're kind of all being multiplied, but we also have a divide by 4 sitting there ready to go, right? So keep in your mind the lowest running total right now, which is 2. And then that 2 can be multiplied by 2, which gives us 4, right? That's this here. And then immediately you can divide by 4, right? Again, what does all this do? Our lowest running total is once again equal to 1, right? Let's go through that again. 27 divided by 7 divided by 3 is equal to 1. 1 times 18 is 18. 18 divided by 9 is equal to 2. 2 times 2 is 4. And 4 divided by 4 is equal to 1. And now, whatever is left is just times 6 here, by the way. So just multiply by 6. And this is really easy. This gives us a final answer of equal to 6. All done. Easy, squeaky clean. There's no messing about. We just basically went right out and found the answer. Okay? So that's how you want to always do these questions. Number 1, look out for any lowest running totals, which gives you 1. And then just add on and just try and keep that number as small as possible. Okay? I also want to emphasize one more thing while we're already here. Which is that you don't want to go left or right. If we did left or right in this case, we would do 18 times 6 times 21. Now, even the most adept of you watching this video probably can't do this in your head, right? But you can do this in your head, okay? And so that's the idea there. You just want to be able to apply yourself in that way, all right? Okay, cool. I believe that this question really symbolizes the rest of the exercise, so I will leave the rest three of these questions for you to do as a homework type of an exercise. Okay? So go ahead and try and do them on your own and really go through all the principles we've talked about, right? Circle your division signs. Try and find lowest running totals that equal to 1. And then use all that knowledge to help support what you already know about how this works. Okay? That is that. All right. And that's it for today. Thank you so much for listening, and I will see you in the next one. Goodbye.